Good morning, everyone, and thank you again for inviting me back this year to give a little bit of an update on a project that was so generously supported by the network and I presented last year. But I think it's really important that I give a little background to the project for those who weren't here last year. So the study itself is called Investigating the Presence of Abnormal Prion Protein in Human Pituitary-Derived Growth Hormone, the implicated batches in UK cases of iatrogenic CJD. And I know that that has been a topic of the discussion this morning. Now, a little bit of a background, which I know Richard and Simon have produced today. So we need no reminding that, like all neurodegenerative diseases, human prion diseases are diseases of the brain. And we've heard how within the brain, we have this normal prion. My diagrams are much simpler. We have this abnormal prion protein expressed in the brain. And in those individuals who have prion disease, we also have an abnormal and misfolded form of this protein. Now, again, this misfolded protein can occur within the brain either through the spontaneous conversion of the normal to the abnormal form that we see in the sporadic and the genetic forms, but it can also be, due to the infectious nature, be acquired. Now, looking a little bit more in depth, because this is important for the methodology that we're using for this study, the presence of the abnormal form of the protein in the brain acts like a seed. And this seed, when it interacts with a normal form of the protein, causes this normal protein to misfold and take the form of the abnormal. And as Simon pointed out, this starts a chain reaction where we get the accumulation and the build-up of the abnormal form, and this becomes aggregated in the brain. Now, microscopically, the brown accumulations that we see here are what the abnormal prion protein looks in a technique that we use called immunohistochemistry. And we know that the accumulation of this abnormal form can cause the cellular death, the death of cells, and we get this spongiform change that's so characteristic of CJD. Now, CJD is the most common form of human prion disease, and we know that it can be classified according to into three forms according to the cause of the disease. And our project's focusing on the smallest, but nonetheless most important subset of diseases, and that's the acquired forms. Now, the acquired forms of the disease can come through the transmission of the abnormal protein we've seen from bovine to human, as we've witnessed with variant CJD, but also from human to human transmission. And this is referred to as iatrogenic CJD cases. Now, throughout the world and here in the UK, the vast majority of iatrogenic CJD cases have occurred in recipients of either a human duramater graft or in recipients of, and we say, human cadaveric pituitary-derived growth hormone. Now, just a little background on human growth hormone. It started in 1959 as a clinical trial for the treatment of children with growth hormone deficiency. The human growth hormone itself was very crudely extracted from pituitary glands collected from autopsy patients, well, autopsies. The treatment involved weekly and intramuscular injections for periods ranging from anything for 2 years up to 10 years. Now, the clinical trials and this treatment began really before the transmission of human prion diseases was confirmed, and also prior to the first case of iatrogenic CJD in a corneal graft recipient in 1974. The first cases of CJD associated with human growth hormone were identified here in the UK and in the United States in 1985. However, when we're talking about the subject of human growth hormone, it's extremely important to really be aware that scientists did alert the MRC and the Department of Health to concerns over possible contamination of the human growth hormone with prions as far back as 1976. So in many ways, there was an opportunity to prevent some of the contamination of these patients. In fact, it was the subject of a High Court case in which the Department of Health and the MRC were found to be negligent. Now, over the human growth hormone programme, over 1,800 patients were treated. And since 1985, there have been 81 deaths from human growth hormone associated iatrogenic CJD. If we look at the annual incidence, we can see that somewhat reassuringly, the numbers seem to be in decline, but as we've pointed out, we still do see some deaths, and as recently as this year. So finally, onto the study. So we have quite a very simple question that we're asking. Can we detect the abnormal form of the prion protein in the human growth hormone that was manufactured in the UK? We have access through a collaboration with the National Institutes of Biological Standards and Controls to a large proportion of human growth hormone samples. And this includes what we believe to be some of the implicated batches. That's those that are thought to be potentially most contaminated, and also those that much lower risk. Now, so why are we doing this? Well, really, from a scientific point of view, we really want to assess the long-term stability of the misfolded protein in these aliquots, some up to more than 40 years. And through biochemical analysis, we're hoping to deepen our understanding of the iatrogenic CJD epidemic. But perhaps of more public health interest, we really look at this as an opportunity that we are maybe able to provide some additional information on some of the specific batch numbers that may be more implicated. And this could potentially allow us to refine the current assessments of those individuals thought to be at risk. So how are we doing this? Well, our methodology involves two techniques that were mentioned earlier, and these are techniques that really try to mimic the conversion process in the brain, and that is the real-time quick induced conversion assay, the real-time quick, and the protein misfolding cyclic amplification assay. Now, today I'm just going to focus on where we are with our real-time quick results. And this is the methodology of the real-time quick. So thinking of the conversion, rather than the brain, we are using a 96-well plate. We need a supply of a normal prion protein, and we have that through a recombinant protein. In order for conversion to take place, we would need a seed of the abnormal form, and that's where our human growth hormone preparations will come in, our experimental samples. And by incubating these through periods of shaking, which disrupts the aggregates, and the addition of a fluorescent marker, we are able to watch to see if there's any conversion in real time. Now, before we look at the human growth hormone samples, it's really important for us to validate our method to check that none of the components within the human growth hormone actually have a detrimental effect on our assay. So we have done this by testing the effect of the addition of human growth hormone to the seeding of real-time quick reactions with sporadic CJD brain homogenate, which we know converts efficiently. So with the addition of the human growth hormone, we'll be able to detect whether we see an increase in the seeding, whether there is any inhibition, or, which we hope we get, there's no effect in our assay with the addition of the growth hormone. So if we look at this table, firstly, this is actually an inventory of the samples that we are looking for. We have a total of 115, but these comprise 53 different batch numbers. And you can see here that within these batch numbers, we have 5 different preparation methods. So it's extremely important that we try each of these preparation methods. So we have assessed the real-time quick amplification with each of the preparations. So we did this, we reconstituted a single vial. The growth hormone is a powder that we need to add a saline solution to, which we call reconstituting it, originating from each method. And we did this by trying as best we could to select on the basis of lowest potential risk of contamination. And we assessed different concentrations to see if there was a concentration effect. Now, because we know there was one preparation that was most implicated, we have also taken the decision to look at this anonymised. Now, this is an example of an output that we've got from the real-time quick. This is the work of Alex Peden here, who is here today, is going to speak next. He's really carried out the majority of the experimental work. So I'm not going to pretend that I understand this graph. I much prefer a very simple table. So what we have here is a table of the different extraction methods. And wait, let's see, is this working? No. And then the first column, I've put 0%. So that's where we've not added our human growth hormone. So you can see that we get seeding activity within each, with the sporadic CJD. And you can see where we in the 0.1%, the 1%, and the 2.5%, that's our addition of the human growth hormone. Now, at the 2.5%, you can see that we have seen some inhibition in the reaction. So it has actually interfered with the conversion. 0.1%, there's also some indication that there is partial inhibition. So we've started our analysis using a 1% concentration of human growth hormone. And the stage we're at just now, we have all 53 preparations have been reconstituted and are stored in the -80. All samples will be anonymised prior to examination. And I'm happy to say that the initial analysis of all the human growth hormone preparations are almost complete. And just to summarise the results so far, so we have observed seeding activity in one sample. However, what we will do, which we do as a diagnostic, we will carry out additional real-time quick assays in order to confirm this observation, and really to define whether we are going to classify this as a positive sample or a negative sample. Now, the next stage is to obviously complete this. Any samples that we get of interest, we will be carrying out PMCA, and then it will be a matter of gathering all the data together, and we will be ready to hopefully publish our findings. And I'd just like to, am I okay for time, Richard?
Yes.
Oh, perfect. So obviously, I would like to acknowledge the CJD Support Network for supporting this work. And these are all members of the laboratory and our collaborators, but a particular shout out to Alex Peden, who really has carried out all the experimental analysis for the project.